Welcome to Competitive Edge Dynamics USA. This is one of 3 international locations for office, warehousing, and distribution. Today we're going to be talking about the CED M2 chronograph system. So let's go in and get started. Today, before we go to the range, I'd like to talk to you a little bit about the features and functions of the CED M2 chronograph and how you can get a better performance and use out of this product. All chronographs are affected by certain variables, including temperature, altitude, sunlight, muzzle blast, water, snow on the ground, or time of day, and the temperature of the gun in use. Therefore, these variables will affect the performance and results you get from this product. Different brands of chronographs vary dramatically in accuracy, usually based on price range and the quality of the sensor and diodes being used in the product. Accuracy can range anywhere from less than 0.25% up to 8% in readings. The CED M2 chronograph has been laboratory tested to be 99.8% accurate using sunlight and 99.95% accurate using infrared screens. Today we'll talk a little bit about both. The CED M2 chronograph comes complete. That comes with daylight screens, a 2-foot mounting bracket, 2 sensors, a main unit, and 20 feet of shielded cable. Like all other chronographs on the market, they come with daylight screens, and you use sunlight as your source of light and power. Therefore, the chronograph itself only needs a 9-volt battery to operate. One of the nice features of the M2 chronograph is its main unit. It's a keypad operation and the same layout as a calculator, and each function has an independent button. This allows you to immediately go to the one that you need without toggling through 5, 6, 7 repetitively in order to find what you want. What I'll do is go quickly through these functions as we are offered. The chronograph gives you high, low, average, extreme spread, and standard deviation at a touch of the button. It allows you to switch between feet and meter. If a velocity is under 1,000 feet per second, it'll give you that velocity to 1/10 in decimeters. The chronograph also features a built-in calculator and power factor function. Power factor is used for many competitions, including IPSC and IDPA matches. Later, when we go to the range, Greg Lent will explain to you how to calculate power factor using the chronograph. For now, we will go into some more of the basic variables that affect readings. The CED M2 main unit has the largest display in the industry. It has a keypad function which allows you to obtain the information you want at a single press of the button. No toggling is involved like many of the other brands on the market. The keypad is laid out as a calculator. It has an on-off button, a feet and meter selection, a string selection, a clear, a review, an edit, omit, standard deviation, high, low, extreme spread, average and high 3 average, a storing button to store your strings, an alternate clear, which is a function that can be detailed in the book later. We have a speaker function, which is unique to the CED M2. It allows you to hear your velocities as well as see them. And a power factor calculation, which will be described in more detail by Greg Lent at a later time when we go to the range today. To elaborate on a few of those features, all chronographs have basic features like high velocity of a string, low velocity of a string, extreme spread, which is the difference between a high and a low, average, and most chronographs will give you a standard deviation. The CED M2 goes beyond that. It gives you a high 3 average, which is quite often used for IPSC and IDPA calculations. It gives you a more precise standard deviation, where you have 5 or more rounds calculated in a string. And we also provide 2 methods of standard deviation in our data collector, which is our software, which can be attached to a PC and uploaded later. In addition, you have an edit and omit function. The edit function takes the velocity that you no longer want out of your string calculation, but keeps it in memory, so later you can go back to it on your downloads if you want. An omit function omits it completely from memory. A unique feature of the M2 is a speaker function. No other chronograph in the market offers this for you. If you're on the line and you're sighted in at 100 yards and you do not want to lose your point of aim, you can turn on the speaker function and you can hear your velocity reading in addition to seeing it. This is a nice feature and it helps you keep your point of aim at all times. In addition to what I've just described for you as functions and features, the M2 provides up to 1,000 velocities in memory and 500 strings. It allows you the ability to recall a string at any time, and you also have the ability to edit velocities or strings prior to storing them in memory. The first step that you need to do is to plug your 2 sensors into the input jacks on the back of the main unit. It is important that you plug the start into the start and the stop into the stop. Take the 2 sensors and put them together so that they're touching with the holes that would normally go in a mounting bracket. You want them sitting on a table and touching together. Turn on your main unit. Now, in this case, we put this sensor in the start and this sensor in the stop. So what I'm going to do today is turn on our flashlight, and we are going to swipe this light across the sensors as fast as we can. And every time we do that, we are getting a reading on the system. This one says 279.4. The next one says 173.6. Now, because of the inconsistency of my hand, I'm not going to be anywhere close to accuracy, and it's going to vary dramatically. But as long as you're swiping faster than 50 feet per second and holding the flashlight 3 to 4 inches above the sensors, you will get a reading, 177.8. Now, we're also getting an EO warning system and error messages, and that's happening because of 2 things. Number 1, I'm inconsistent, so that the strings are starting to average out more, greater, or less than 7% of average, and that's giving us a warning. Number 2, I may not be perfect in the way my hand swipes, and I may be getting more impulse on one sensor than the other. The only thing that's important about this test is that we use it to determine that the equipment is functioning, and that's what we've just done here. At home, simple before we go to the range. And it's a simple way of making sure that our sensors, our cable, and our main unit are functioning properly. All chronographs are affected by many variables, both indoor and outdoor, that can affect your performance. Today we'd like to discuss some of them in our hopes of helping you improve your range time and obtaining the best results that you can get. While shooting outdoors, some of the variables that will affect your performance include the position of the sunlight, muzzle blast, temperature, snow or water on the ground, how hot or cold your barrel is, the altitude of which you're shooting. The 2 primary factors in all chronographs are sunlight and muzzle blast. They account for almost 90% of all problems that shooters can occur in use. One of the most important variables to good chronograph use is balanced sunlight. If the chronograph does not have a balanced amount of light on both sensors, you will not get a good reading. These top screens diffuse that light, and allow the sensor to detect a light drop or shadow of the projectile. That is very important because that's what triggers the chronograph and allows the internal clock system to calculate your velocity. Sunlight needs to be on both these top diffuse screens evenly. The ideal sunlight would be to your left or to your right of the chronograph use so that the sun comes in high enough to be diffused through these screens and balanced on both sensors. We don't want light to come through and directly shine on the sensor itself. So if the light is behind me or in front of me, I'm going to get more light on one sensor than the other one, and you're not going to get good results. It's very important to make sure that that light is high enough in the sky to diffuse through the top screens and balanced on both sensors. Now that does not mean that you can't chronograph at 9 or 10 in the morning or 4 or 5 in the afternoon. Depending on where you are and the time of year, you may have more than adequate light or you may not. There is no given variable for chronographs and sunlight. The M2 has a very advanced digital system, and the sensors will read in 40% less light than some of our competitors. However, there may be times when 3:30 in the afternoon is the finish of your day, or a very cloudy cast day, you may not be able to get the performance that you want. These are variables that all chronographs experience and must deal with. One solution to low light conditions are infrared screens. These are CED patented screens which provide a stable, consistent light source for use in low light conditions, indoor, evenings, or no light. Actually, they prefer to be in the dark. They like it that way. Infrared light is not visible to our eyes. Therefore, the screens have a red and green light system on them that will notify you that they are turned on and performing correctly. They do require AC source of power, which comes with each screen set. If you're on the range where there is no electricity available, we have an optional battery rechargeable pack that can be purchased to provide you up to 8 hours of field use. These infrared screens replace the top diffuser screen. They also come with similar side arms, but 2 of them have a jack on the end, which allow you to plug in the battery pack or the AC connection. The infrared screens provide you the ability to continue chronographing later in the afternoon and evenings when there is not sufficient sunlight available to do so. The second most important cause of problems in getting accurate readings is muzzle blast. Due to the wide variety of rifles and handguns on the market, there is no single distance in which you should be placed behind the chronograph in order to achieve the best results. Each rifle or handgun can give you a different performance with muzzle blast. Therefore, it's important that you test each one in order to find the best distance to be positioned in its use. With handguns, I have found 5, 7, 8 feet most of the time is adequate. However, with rifles, we have had experience with distances up to 20 feet in some cases. Therefore, I think it's very important that you start at the furthest distance possible with each one of your rifles, and if you get accurate velocities at that distance, you can move forward until you find your point of no return. Record that, keep a record of it, and then each rifle you know exactly what distance is giving you the optimum performance. The reason muzzle blast is a problem is that if it's too strong, it can be detected by the sensor and registered as a projectile going across. Now, this then can result with a sensor detecting 2 impulses, in which case you would get an EO or an E1 error reading. If the projectile then did not pass through the second sensor, you get no reading at all, you just get the warning. However, if the projectile, the bullet, does cross over both, plus muzzle blast is picked up and detected, you could get a velocity reading plus the error readings, in which case it is very hard to detect whether the reading is accurate or not. If you see the screens fluttering while you're shooting, it's usually a clear sign that you're too close and the muzzle blast is affecting your screens and performance. Therefore, move back, as I described, until you get to the point where you get an optimum performance. Don't necessarily think that your chronograph is not working because you're getting zeros. You have to look again at balance light and muzzle blast to make sure that you've accounted for both of those variables. In obtaining very accurate readings, it's also important to remember that your projectile should be parallel across both sensors. If you're shooting on an upward slope or you're shooting from a higher position down, you may find that the projectile passes over the first sensor higher than it does over the second. In essence, that will give you a slightly inaccurate reading. It is very important then to align yourself so that you're shooting as close to parallel over the sensors as you can. Also remember that these sensors have a single diode that are picking up that light drop of that projectile. In essence, the shadow. If you have a large bullet, a 45 ACP weighing 230 grains, crossing over at 800 feet per second, it's like a fly crossing in front of your eyes, and it's much easier for the sensor to detect in lower light conditions. However, if you're trying to shoot with a pellet or a 223 traveling at almost 3,000 feet per second, now you have a much smaller projectile, and that requires a greater amount of light for the sensor to detect that drop. Think of it like a fly crossing in front of your face or a gnat crossing your face. One is much easier to see than the other. Two other problems that can occur when chronographing, especially if you live in Arizona where you have a lot of desert, or you live in the Northeast where you have a lot of snow, and those are called glints. If you're chronographing on a bright surface, such as the sand in the desert, snow on the ground, or wet grass after a fresh rain, the light from the sun can reflect off the ground and bounce back up underneath the projectile. And what this does is it cancels the ability of the sensor to see the shadow of the bullet because there's as much light underneath it as there is on top. Therefore, it's important that if you're in these conditions and you find you're not getting readings, if you're in an area where you can put down a black tarp or some dark reflective surface that prevents reflection, do it. If not, try to clear an area away or move to another location. Or you may have to move to another time or day. Also, when we're speaking of snow and northeast conditions in the wintertime, keep in mind that the chronograph uses a liquid crystal display. All liquid crystal displays will start to solidify under freezing temperatures. It slows down the internal performance and can damage if it freezes solid. We do not recommend that you use the CED chronograph in sub-freezing temperatures for this reason. Another important factor that we have to talk about in the setup of the chronograph is the spacing of our sensors. We have designed the M2 with a custom square mounting bracket that is a precise distance it's supposed to be for our internal firmware system. However, if you mount the chronograph and you do not push the sensor on completely, and you have even a 1/16th to an 1/8 of an inch difference, that can affect your readings. At 3,000 feet per second, that could be 40 to 80 feet per second, or maybe 1 to 1.5% fluctuation. Therefore, it's very important to make sure you slide the sensor on completely, tighten it underneath. We have a custom plate, pressure plate on the sensor. You can tighten it up, and you're then perfect spacing to get perfect results. Two other problems I'd like to mention are cell phone communication, radio waves, and high tension power lines. Both can affect readings on chronographs. In the case of the M2, you'd have to be talking on your cell phone within about 6 inches of the sensors to affect it. Therefore, it's highly unlikely that you'll be doing it. However, in the case of high power tension lines, you might be located within 50 or 100 yards of them, and if they're emitting enough electrical static into the air, it could affect your readings. Both of these are unusual, and you probably will never incur them, but I wanted to mention them for you. Another important thing worth mentioning when using the infrared screens are that these are designed to be used in low light conditions. They're not designed to be used when you have adequate, good, balanced sunlight. If you try using an infrared screen outdoors under bright sunlight, and the sunlight is also coming down in addition to your infrared, you may find an imbalanced amount of light occurring on one of the sensors, which will give you poor results. Also, if you have an overcast day and you're using the infrared top screens, they are too thick to allow proper diffusion of light. That's the whole purpose of the daylight screens. They're thin and they diffuse light. Now, if you're outdoors and it is cloudy and overcast, Mother Nature is providing the diffusion that you need. If you're not getting enough light to get recordings and velocities, you can try removing the top screens, leaving the side arms on as a shooting window, and let Mother Nature be the diffuser. Now, this may allow you to get recordings for an extra 15 minutes to a half an hour late in the afternoon or in lower light conditions on a really heavy overcast day. Chronographing indoors presents a unique circumstance of problems for all chronographs. The type of range being used, the length, the width, the height, echo problems, sound wave problems, and in most cases, fluorescent lighting. All chronographs hate fluorescent lights. They flutter, and when they flutter, it's detected by the sensor and will fill up your chronograph very quickly with false readings. It's very important that you do not allow fluorescent light to interfere with the chronograph's use. Either turn them off or put a cardboard cover over the infrared screens so that the fluorescent lights do not interfere or reach your sensors. In the case of the M2, the digital circuitry and advanced firmware is so fast that it will also pick up the fluttering of some incandescent bulbs. Therefore, we do not recommend you using incandescent lighting with the M2. It might work depending on the bulbs that you're trying to use, and it may not. We designed it for use with the infrared, and we highly recommend that you use it that way. A large problem with indoor ranges are the high amount of echo and sound waves that bounce back off of walls. If the sound waves are strong enough, they can come back off the back or the side walls of a bay and interfere with accurate readings. If this happens, then you're just not able to use your chronograph in that particular location. Try finding an open area of the range indoors and set your chronograph there. The main unit could be back with you and the tripod 20 feet out in an open area. Try to get as much spacing as you can on all sides to prevent this from happening. Keep in mind on an indoor range that muzzle blast is amplified much greater than it is outdoors. Therefore, if you're using a rifle outdoors at 10 feet or 12 feet, you may have to be much further back indoors in order to eliminate the muzzle blast problems that could occur. The wide range of velocities of the M2 allow you to record from 50 feet per second up to 7,000 feet per second. Therefore, it doesn't really matter whether you're chronographing a bullet, a pellet, paintball, an arrow, a steel ball, rubber bands, or anything else that you want to shoot across it, as long as it's going faster than 50 feet per second and slower than 7,000 feet per second. In fact, we have many customers who use our CED-M2 chronograph for a wide range of uses outside of the shooting industry. I'd like to touch just a moment on archery use. The arrows will be detected on the M2 chronograph and you will get readings. However, the advanced circuitry is so sensitive it will pick up the fletching on the arrow as it rotates across and thereby give you a double reading on one of the sensors. You'll get an accurate velocity, but you'll pick up an E1 or an EO error warning sign along with it. You can ignore these if you want and just record your velocities, which should be accurate. Or you can remove the fletching from the arrow, which will solve the problem. For all you users who have a range or a location of use that provides you a little more flexibility or permanent structure, there are two things I can suggest that will enhance your performance greatly. And as it relates to muzzle blast, I've had many customers tell us that they've created a blast screen. This is easy to do with a piece of plywood. Simply purchase a piece of plywood that is standing taller than your top screen and a little wider than your chronograph sidearms. Cut a 2 to 4 inch diameter hole about 2 to 3 inches above your sensors and place the screen upright in front of your chronograph. Now when you shoot through that, the muzzle blast will dissipate on the screen, allowing the projectile to go through and give you very accurate results. This will allow you to actually position yourself closer to the chronograph and still get good results.
Hello, my name is Gregory Lent. I've been Chief Chronographer Unit for the United States Practical Shooting Association since 1992 and working with CED products in particular for the past 10 years. We're going to look at the assembly procedures for the chronograph today. When you open your CED box, you'll find your instruction manual, your data collection CD, USB cable, sky screen assembly, base mount, main unit, and your sensors. We're going to go ahead and assemble these now. Taking your base mount unit, make sure the sensor is firmly seated and tightened in place. Repeat the same with the other side, making sure everything is firmly seated, otherwise you'll have errors in your readings. A very small distance here will greatly magnify your error rate. The mounting base comes with a bracket for attaching directly to standard tripods. It also comes with an accessory is also available for a table mount. Taking your sky screen supports and a sky screen, inserting them in each end. Once the sky screens are in place, take your cables from your sensors and install them in your base unit. For the first sensor will be start, the second one will be stop. Alrighty, you've seen how easy it is to assemble the CED chronograph. The only thing left to do is to install a 9-volt battery, turn the unit on, put your hearing protection on, and shoot. Okay, you fired your first few rounds over the chronograph. You're ready to check for power factor. You need to pull a bullet from the cartridges you've been using. CED also makes a handy pocket scale. Been on many, many airlines with me. Never let me down. Comes with a collapsible wind shield. Turn the unit on. And the bullet weighs 115.5 grains. Okay, we pulled and weighed our bullet. It weighs 115.5 grains. On the main unit, we're going to push the average button from our 5 shots. Average gives us 1,001 feet per second. We'll push power factor button, enter the bullet weight, 115.5, and then the equals, which gives us power factor of 115.6. Easy as can be. The errors that come up on the CED chronograph, they're basically 3. You have one that gives OR out of range, which is about 7% above or below your string that's in progress. That may or may not want to be omitted. It could be an indicator of mixed ammunition. It could be an indicator of your powder measure being out of adjustment. The E0 and E1 readings. E0 reading will be the front sensor missing the shot where the back sensor picks it up. It could be from light shifting or debris on the sensor itself. The E1 reading is a missed stop sensor error. This can be from light shifting on your back sensor, or it could be from pulse or muzzle blast hitting the front sensor and not the rear. One of the primary problems that shooters are having with any chronograph system is light intensity and light angle. The way the chronograph works is it senses the shadow of the bullet as it crosses the first sensor, starting the timer, crosses the second sensor, stopping the timer. The sensor eyes basically need to be in shade so that they can read the top of the sky screen, whether you're using sunlight or infrared. If you have light washing into this slot, you're going to get either erroneous errors, erroneous readings, or no readings at all. Okay, putting together everything that we've learned thus far, we're using CED chronographs in tournament play, and when we use it in tournament play, we use 2 chronographs in series in case one unit has a failure of one way or another, an error message that we don't like. We also use it as a cross-check. Typically, the chronographs will run within a few feet per second of each other. We have them in a box like this in order to compensate for the sun's moving across the sky. We have, by using our CED infrared light emitters, we're able to have consistent light over the sensors every shot, every day for the entire tournament. We close the box up. We block out as much sunlight as possible. The inside of the box is painted flat black, so we have no reflection of light. The entry point of the chronograph is a small hole, so it's a built-in blast shield. Again, we're shooting both open, limited, and rifles through here, so any blast that happens stops at the front, and we get more error-free readings across both chronographs. To build your own box like this, instructions are available through CED. Send them an email and they'll be happy to send the instructions to you. If you want to make one on your own, we advise that you have a side opening box so you have easier access to the side. Hinge it and make it so that you can close it, make it light free and weatherproof.